So we have already learned about factorials, fundamental principle of multiplication and that of addition. Now here we come to the main topic of this chapter, which is permutations, right? So what are permutations? Basically, permutations are just arrangements of selected objects. Let me write over here. This is arrangement of selected objects. So what you do is you have a few objects, you first select a few of them and then you arrange them. So the arrangement is the major part of it. First we make selections, we have a group of objects, we select a few and then we arrange them. So that's exactly what is the meaning of permutations, but we will not understand the meaning of permutations until and unless we apply it into a problem. So let me give you an example. Let's say we have 3 alphabets: A, T, C and G. So if you have studied a little biology, you would be knowing that these are the bases of nucleotides that form codons, which basically code for the amino acids in our body. But right now we are not concerned about that thing. We just know that we have 4 alphabets: A, T, C, G. So the problem statement is permutations of the 4 letters A, T, C, G taking 3 at a time. So permutations of the 4 letters that are given A, T, C, G taking 3 at a time. So what we are supposed to do is that we have to select 3 at a time. We have to select 3 alphabets from A, T, C, G and rearrange them. So let me give you an example. First, let's say we have chosen A, T and C. So now we can just rearrange them. First is A, T, C is one arrangement. Another arrangement could be A, C, T. Another arrangement could be T, C, A. Right? So I want you to pause the video and think about yourself, how many such permutations are possible. First you select 3 alphabets and then you rearrange them. So how many such rearrangements are possible? Pause the video right now and think about it. So let's find out the solution of it. So since we have already done 3 permutations, so let's write another one. Let's skip T in the first place but rearrange A and C. Then another thing we could do is we can keep C at the first place and A, T, C at the first place and swiping the place of T and A. So we have already got 6, right? Now let's include another one. So these are all the permutations that are possible with these 3 alphabets. Now let's select others as well. Let's select for now T, C, G, right? So with TCG, what we can write it, we can write is TCG, we can write TGC, we can write GTC, we can write GCT, and we can just go on. If you have written all the permutations, you will find out that there are a total of 24 permutations possible. 24 permutations that are possible of selecting 3 alphabets from ATCG and rearranging them. So it's quite a tedious task, right? You have to write all the permutations. You have to first select 3 and then write all the permutations, and it will get lengthier and more trickier when you would solve some really tough questions of permutations and combinations. But to our help, there is one very important formula, a theorem or a formula, whatever you want to call it. It's so important that it has become a formula only. Let me write it, which will make our life easier. So here we have the formula. Let me write it. NPR, or P inside bracket NR is equals to n factorial. Now you would know the importance of factorial. N minus R factorial. So this is a very important formula which you should know. You should remember this formula. It's a very useful and important formula as well. So what exactly this formula is? Let me tell you. Here I have written NPR. These are just notations. NPR or PNR. These notations stand for number of permutations or arrangements of n distinct things taken R at a time. Let me write it. So these notations, what these notations say is, this is number of permutations, or you could say arrangement of n distinct things taken R at a time. So what this says is that if you have n objects, you are selecting R objects out of them and you are rearranging them, right? So in that case, NPR, that is the number of arrangements of n distinct things taken R at a time, is given by n factorial upon n minus R factorial. So this is exactly the formula, and let us apply this formula to the above question again. So let me write the question again in a in a more legit way. So let me write the question again. What is the number of permutations of 4 letters A, T, C, G taken 3 at a time? This is exactly the question that we solved earlier, but we took cases, right? Now we would be using the permutation formula here. So for giving you the solution, let me write the solution. Yeah, did you notice that we are given 4 letters, out of which we have to select 3 letters, right? So here the 4 letters is what we call N. We have 4 letters, out of which we have to select 3 first. So here this 3 is our R. So we have 4 letters, we have to select 3 and then we have to rearrange them. So according to the formula, we can write NPR is equals to n factorial upon n minus R factorial. What are we given? We are given that we have 4 letters, out of which we have to select 3 and then rearrange them. So plug in the values, we get it's 4 factorial upon 4 minus 3 factorial is equals to 4 factorial upon 1 factorial, which is nothing but 4 factorial, which is 4 multiplied by 3 multiplied by 2 multiplied by 1, which comes out to be 24. As simple as that. What took us so much time to take the cases and count, with this formula our life has become easier. And that's why this is the power of this formula, this permutations formula. How important it is, you will understand while solving linear problems in which there are so many cases that you can't count them. And that's why you just plug in the values of N and R and you just tada, you just get the value of the number of permutations of n objects taken R at a time. So that's it. The main part of the formula of this whole video is this formula, this very important formula, which I would request you to take a note of. That's it.